Welcome to the Scientific Worldview, the podcast where we explore the big questions in science and philosophy. I'm Daniel Gambacorta.
I'm Atana Shannon.
Tana, on this podcast, we've talked a lot about genes, how genes influence behavior, a lot of gene talk. Last episode, we talked about culture. This episode, let's begin by talking about the interplay between genes and culture. Genes and culture evolve together. There is gene-culture coevolution.
That's cool.
Changes in gene frequencies affect culture, which leads to culture selecting for different genes. And then these different genes affect the culture, then the culture selects for different genes, so on and so forth. For example, humans were hunter-gatherers for hundreds of thousands of years. About 10,000 years ago, agriculture hit the scene. Agriculture was a huge deal. Human groups transitioned to mostly farming. If your culture goes from hunting and gathering to farming, this is a massive change to the source of traits that make someone successful. The traits that make you a successful hunter are not the exact same traits that make you a successful farmer. So the features which promote survival and reproduction change when a group switches to farming.
Okay.
According to one theory, there was selection for conscientiousness during the agricultural revolution. Farming requires planning, thinking a lot about the future. Also, it is extremely arduous. Looking at recent human groups who forage or farm without advanced technology, anthropologists estimate that farmers spend 50% more time working to provide themselves with food compared to hunting and gathering.
Right.
You ever farm?
I have farmed. It's fun.
What did you farm?
We had a veggie farm for a little while. Not a big scale. It was more like a garden, but
okay. So you've done some light, fun farming.
Some light for fun farming.
Apparently, for our ancestors who farmed to survive, it's a lot of boring, repetitive work.
Right.
So it's plausible that the agricultural revolution led to selection for conscientiousness, like the personality trait conscientiousness. Those who were successful farmers were good at forcing themselves to work all the livelong day. And these conscientious farmers survived and reproduced more effectively, and the human species became more conscientious on average.
Right.
Another example of gene culture coevolution involves the ADH1B gene, our favorite gene. Am I right?
Obviously.
This gene is extremely common in Southeast China, pretty common in the Middle East. The ADH1B gene affects alcohol metabolism. People with the gene experience increased dizziness, nausea, and flushing of the skin when they drink. The gene also makes hangovers worse. Turns out the distribution of this gene is extremely well predicted by how long ago parts of the world started growing rice. In places that engaged in rice agriculture a long time ago, the gene is much more common. Why would this be the case?
I was just going to ask you that.
Do you have any guesses?
Something about metabolizing rice? Like digesting it correctly?
It has to do with metabolizing rice alcohol.
Oh.
It seems like as soon as people started growing rice, they figured out how to make rice wine.
Right.
That's your first priority. How do I get drunk off this stuff? And access to alcohol means the potential for alcoholism, which is bad for your health.
Right.
So in these parts of the world, there was selection for resistance to alcoholism. People with this gene were less likely to become alcoholics because it makes drinking less pleasant. So the gene spread in places where historically alcoholism was more of an issue.
Interesting.
And even today, this gene makes someone much less likely to develop alcoholism.
Yeah, that would make sense if you experience all those symptoms when you consume alcohol. Very cool. Is that something that's also present like in Eastern countries? I mean, Western countries?
Are you talking about the gene?
Yes.
Yes, but it is less common.
Okay.
And it depends on where you look.
Yeah. And about your genetics, I assume.
Because there's been a lot of gene flow, so to speak.
Yeah.
People move around and marry people from other cultures. And so genes get around, Genes get
I
around.
get around. I got you.
Final example of gene culture coevolution involves milk. Some people can drink milk with no issue. Some people can't. Are you a milky?
Not a big milky.
Well,
It hurts my tum.
Okay. Healthy babies come equipped with the enzyme lactase, which allows them to digest milk. By age 5, most people cannot break down the lactose sugars in milk. Their body cannot make use of all the nutrients present in milk, and a lot of people have gastrointestinal issues like you. They get the milk tummy ache.
Tummy ache survivor over here.
EAS. For some, the ability to digest lactose milk sugars persists into adulthood. Some people are milkies. There's high rates of lactase persistence in Western Europe, especially the UK and Ireland. There's very low rates of lactase persistence in China and South Africa. And to be clear, we're talking about genes here. Some people are genetically predisposed to be able to drink milk into adulthood. Some people are not.
Right.
So why do you think this is? Why do the Irish and the British, why can they enjoy their milkshakes without the tummy ache?
I'm thinking tea. Those are big tea cultures.
Okay. So maybe they've been drinking tea for so long and putting milk in the tea?
Yeah.
Okay. And where would that milk be coming from thousands of years ago?
Have you seen those fluffy cows they have?
I have not seen the fluffy cows, no.
I think they're actually Scottish, but they're super cute. They're called Highland cows.
Okay. But you are gesturing at the right answer. It has to do with the presence of domesticated animals that can be milked. So that's one major factor.
Right.
In parts of the world where they domesticated cows, fluffy cows, sheep, camels, horses, goats, thousands of years ago, there was selection pressure to be able to digest milk into adulthood. Because milk has lots of nutrients. So if you're able to digest milk, that is a survival advantage.
I want to know what the first guy to drink milk was thinking.
Yeah, it's a good question. I mean, he was probably very hungry. But a lot of our ancestors were hungry, so you gotta do what you gotta do. You gotta.
I guess. A little strange the first time, probably, for the man and the cow.
Yeah. So this cultural innovation of animal domestication caused there to be an evolutionary selection pressure for lactase persistence. The kinds of people who could digest milk into adulthood survived and reproduced more effectively. And indeed, the peoples of Ireland and the UK have been milking animals for 6,000 years.
That's a long time.
It's a lot of fluffy cows getting milked.
They're so cute. You have to look them up. There's mini ones, and I would die for them.
Okay.
Not to be dramatic.
Well, the other main factor that explains the distribution of genes that predict lactase persistence is whether a culture adopted practices for making cheese and yogurt. is there's much less lactose in cheese and yogurt, so it's more tolerable for most people. Can you eat cheese and yogurt?
I can,
Okay,
strangely.
there we go.
There we
Now,
go.
now we know why. In cultures that made cheese and yogurt, there was less selection pressure for the ability to digest lactose. So people descended from cultures that have a long history of domesticating and milking animals are more likely to be able to digest lactose, and people descended from cultures that did not make cheese or yogurt are more likely to be able to digest lactose.
If they made cheese and yogurt,
Then there'd be
but didn't,
less pressure to be able to digest lactose because the lactose content was lower in those products.
right.
So if you're
But
from
they
a
were
place
still
where you
milking.
did, yeah, if you did milk but didn't make cheese and yogurt, it's most likely
Right.
that those peoples would be able to digest lactose.
Yeah, that makes sense.
All right, next up, let's talk social norms. Cultures encourage some behaviors and discourage others. Cultures can shape behavior through laws. Laws are explicit and formal. If you break the law, you're punished by the state. Cultures also shape behavior through social norms. These social norms are not enforced by the state. They are informal. They aren't written down. And here I'm referring to things like covering your mouth when you sneeze, holding the door for someone if they're right behind you, saying excuse me if you bump into someone. You got
Right.
any others?
Besitos, little
Little
kisses.
kisses? Yeah.
When you kiss your,
Yeah, like when you
uh,
say hello to somebody.
yes.
Okay. It's pretty easy to explain where laws come from. Some person or group of people made some explicit decision, wrote it down. It's not deeply mysterious. But social norms are more nebulous. They certainly operate and shape behavior, but where do they come from? Atana, where do social norms come from?
Society.
Yeah, like how? How did we all
uh,
agree to give little kisses?
that's a good question. I'm not certain.
To answer this, let's take a step back. All right, you willing to step back with me?
Step back now, y'all.
Let's go up a level of abstraction.
Okay.
We are trying to understand a system, in this case, a social system. The system is made up of agents, and we are noticing a complex order. We're noticing all the agents doing the same thing, like when they say hello, they're giving little kisses.
Right.
And we're trying to understand why. Where did this complex order come from? There are two sorts of processes that create complex order within a system: top down processes and bottom up processes. Top down processes refers to an agent or agents forcing the complex order into existence. They are somehow exerting power, they are the central cause of the order within the system. Bottom up processes refers to local decentralized interactions. There's no one running the show. Rather, there's many separate interactions which sum up to a complex order. The complex order is emergent. This is all pretty abstract, right?
Yeah.
Okay, so let's go into an example.
Okay.
You look around at life on Earth, you notice complex order. It does not look random. All these life forms are strangely well suited for the environments in which they find themselves. There's all these complex interactions, like bees collect nectar from flowers, and then while doing so, pollen sticks to their body, and then the bees visit other flowers, and that causes cross pollination, and that's essential to the reproduction of the flowers. So there's this amazing amount of complexity which requires some sort of explanation, does it not?
It does.
Okay. So we could give a top down explanation or a bottom up explanation. A standard top-down explanation is that God did it. That there's this complex order. It was created by some agent who wanted it that way.
Right.
A bottom-up explanation could be evolution. There's a simple process that operates on living things, and if you allow this process to run for a long period of time, you end up with a lot of complexity. According to this explanation, there is no agent who caused bees and flowers to depend on each other. Rather, that interdependency is the product of adaptations, which gradually accumulated in these organisms over a long period of time.
Yeah.
Another useful example for understanding top-down and bottom-up processes within a system is language. A language is made up of words. Where do words come from?
All words are made up.
What else would they be?
I don't know.
But let's say we have an existing language. How do we add a word to the language? Like, how does that happen?
Oh, through a lot of different people using it a whole bunch of times. I think we see this a lot with every generation having their own sort of language. I don't know if you talked to anyone in Gen A recently, but I don't
In
understand a word they say.
in Gen what?
Gen Alpha?
Oh, okay. Yeah, I've heard that term. So they're called Gen A.
I guess so, yeah. Like
Okay.
I'm Gen Z.
Okay. But yeah, I think you're absolutely right. New words are generally not created by the government and forced on people. Rather, words are emergent. Words
Right.
are coined. They spread via imitation, which is prestige biased. And if a word becomes popular enough, it eventually can get formalized as an entry in a dictionary. But the dictionary writers don't decide how a word is used. They just pay attention to how people use words.
Exactly.
So there's no puppet master, there's no central agency that decides how language is used. It emerges mimetically. It's a bottom up process.
Yeah.
This distinction between a top down process and a bottom up process is admittedly kind of fuzzy. And when we're trying to understand our social world, everything's going to be a mixture of the two, but it's still a useful way of thinking about things. Laws are generally best understood as top down processes. And the point that I've been driving towards slowly but surely is that social norms are best understood as bottom up processes. They are mimetic. They emerge as the product of many local decisions. They're analogous to words with regard to how they're created and spread.
Yeah, exactly. That makes sense.
So that's our first key to understanding where social norms come from. They are emergent. The second important fact about social norms is that they are functional. They are doing something useful. They're often a solution to a public goods social dilemma, some situation where if everyone behaves selfishly, everyone will be worse off. The social norm nudges people towards being pro-social in a way that makes everyone better off. An example of a functional norm. In a movie theater, quiet is a public good. We all want to be able to enjoy the movie without having to listen to other people chat throughout it. There is a social norm that you should not talk during the movie. Maybe you like to talk during movies, and when you're at home, you talk during movies, but when you're at the theater, it's expected that you don't talk. Each individual might selfishly benefit by talking sometimes. Some people like to talk during movies, but if everyone who feels like talking does so, then we end up with a theater full of people talking throughout the movie, and that makes the movie worse for everyone. So we have this social norm which coordinates the group. Individuals have to make the tiny sacrifice of not chatting whenever they feel like it, but then we all benefit by being able to enjoy a quiet theater.
Something that they actually have made a top down process at my local theaters here. They have all these commercials before the movie starts where no phones, no talking. If you disturb the movie, you go out.
Yeah, theaters will enforce this. At the very least, it's not a law.
Yeah.
And in actual reality, if you chat during a movie, it's very unlikely you're going to get thrown out.
Unless you're like screaming.
Yeah.
Yeah.
So a lot of what is checking people's behavior is a social norm. It's not just that they're like, I'm going to be thrown out. It's
Right.
like, I'm going to annoy people.
Yeah, exactly.
Now, the fact that there's a social norm doesn't mean that everybody follows it. It's the same with laws. Some people break the law, but many people do abide by laws and social norms. If somebody gets a phone call in a movie theater, they probably aren't going to take the call in the theater. They would probably leave the theater first.
I would hope so.
This leads us to another question. Why does anybody follow the norm? What actually prevents someone from talking during a movie? And let's even assume we're at a theater where they don't throw you out for talking.
um, for fear of social persecution.
Yeah, I think that's a good answer. So one factor could be altruism, that you care about other people, you're willing to make a minor sacrifice for their benefit, but there is perhaps the more important factor that you're pointing to. Norm violators may be punished. If you talk during a movie, someone might yell at you. And I'm not talking about the movie theater. I mean, just other people in the theater.
Right.
Someone might embarrass you. You might have to deal with some aggression. So as long as there's a small percentage of people willing to enforce a norm, it can be maintained.
Right.
Though this leads us to another question about social norms. Why would anybody be willing to enforce a social norm? If you yell at someone for talking during a movie, that's awkward for you. And who knows how the person's going to react? Maybe they would get aggressive with you. So you are paying a cost in order to enforce the norm. So why would anyone ever stick their neck out and enforce the norm?
Most likely they'll have the backing of the majority behind them, so it feels a little bit safer.
It's true, it feels safer, but there's still maybe some cost.
Yeah, absolutely.
So why do it?
That's a good question.
Altruism could be a factor. Maybe you care about the other people in the theater not being annoyed.
Yeah.
But also, norm enforcers are granted prestige. You are performing a public service, so that gives you a kind of status. We appreciate the people who are willing to punish norm violators.
That kind of happened to me last year. There was somebody who was screaming at people in these houses that sit across from my parking lot and screaming profanities at them. So I may or may not have screamed back at them. But my neighbors, they said that I did a good job. They said they were proud of me. So that reinforced my want to scream at more people who were screaming at me.
Just the way you drop those F-bombs. It was art.
Drop an F-bomb.
It was.
Hey, he called me a slur, so
okay.
You know what?
All right. Social norms allow things to run smoothly. They prevent friction and chaos. Here's an example. Say several people are at a store. They each pick up some items. They head towards the cashier. They're all standing near the cashier, and they have a discussion about who should get to check out first. One person says, I have fewer items, so it'll be faster overall if I'm first. Another person says, I'm in a rush, so it's important that I'm first. A third person says, my feet hurt, so I lose the most by waiting, so I should be first. And then a fourth person says, I was the first to approach the cashier, so it's fair if I'm first. Now, the very fact that they're having an argument over who gets to check out first is making everyone worse off. It's wasting everyone's time, and there's no obvious way to decide who has the best argument. To avoid this situation, we have evolved a social norm. There's a rule of thumb that makes this decision for us, and of course, I am referring to
Lines.
lines.
Form a line, people. Single file.
Our default rule is to form a line, which is based on who approached the cashier first. If somebody breaks this norm, they are quote unquote cutting the line, and they face the risk of being punished for their norm violation. The fact that we have a default rule means we don't have to negotiate who gets to check out first every time there's multiple people at a cashier, and that makes everybody better off.
What happens if you have a friend who's at the front of the line, but you just got to the line? Are you allowed to go to the front of the line with your friend?
It's a gray area.
I know. What if you have so many items? Your friend only has one item, and you cut everybody because your friend's there.
You might get called out.
You might. What if you only have one item and you cut up with your friend? Would you still get called out?
I suppose it's less likely.
A gray area.
I'm not a cutter, so I can't speak from experience.
I think I've not done that in stores, but I've done that at like a merch line one time at a concert.
Mm-hmm. How'd it go?
And nobody said anything to me, but I did feel a little guilty.
Okay.
I was like, I promise I'll be quick. It's just one item.
This default rule is not present everywhere. For example, in southern Italy, there's much weaker norms regarding lines. People are less likely to form a line, and what we would call cutting is more acceptable.
I have seen videos of that. And then Americans touring these countries and feeling very frustrated because they're not following similar social norms.
All right, Atana, that pretty much wraps up what I want to say about psychology.
As a whole?
Yes.
Okay.
At this point in the pod, we've talked a lot of science. This is the scientific worldview after all.
True.
Now, I want to talk about the institution of science. How does science work? What are the problems with science?
So many.
Indeed, science is a flawed institution. And just like every other institution, it's not perfect. On this podcast, we've criticized medicine. We've criticized education. We've even criticized democracy.
Now we're going to criticize science.
Now we're going to criticize science, and I want to caveat this by saying we do not criticize these things because we think they are bad, but because we want them to get better.
Right.
So I'm going to criticize science, talk about how it's not optimal. My goal isn't to make people distrust science or to argue that science as an institution is hopelessly doomed. Rather, I want to see science improve. And one step in that process is identifying flaws.
Don't you do science? You're like a science guy, right?
I've been known to do some science.
Notably some science in your history.
Indeed.
I feel like you're pretty qualified to criticize it.
With all that being said, this is how empirical science works. A scientist has an idea. They collect data to test that idea. They write a paper where they explain their idea, and they report whether the data they collected supports their idea. They send this paper to a scientific journal. There are many, many journals. They vary in the topics that they focus on and also their level of prestige. Some journals are higher status than others. Each journal has an editor who is responsible for ultimately deciding whether a submitted paper will be published in that journal. A scientist sends their paper to the journal. The editor reads it. At this point, the editor might decide that the paper isn't good enough or it isn't appropriate. In this case, they would tell the scientist that their paper has been rejected. If the editor thinks that the paper might be good, they will then send it to a number of reviewers. These reviewers are experts in the fields. These experts read the paper, they evaluate it. The experts might conclude that the paper is not very good and tell the editor all the reasons why they think it's not very good. Or maybe the experts decide that it is good, but the paper needs some revisions. After the scientist does all the revisions, if the editor is satisfied, the paper is published. This entire process is incredibly lengthy. On average, it takes 6 to 12 months.
Yeah, that's a long time.
Yeah. The whole point of this rigmarole is that the papers that end up in the scientific journals will be incredibly high quality and rigorous. The journals represent the canon of science. These published papers are the output of the institution of science, which is very prestigious and must be taken very seriously. The most straightforward way to test the validity of the findings of a study is to do the study over again and see if you get the same results. This is known as replication. It is a cornerstone of science. If a study is conducted well, some other scientist should be able to perform the same study and get broadly the same results. The results should replicate. Does that check out?
How often does that happen?
Yeah, we'll get there. We'll get there.
Yes, that checks out.
Okay.
That seems like a big part of the point of science in general, too, is replication. And a major part of the point of writing the paper as well is so that you can replicate with all of the incredible detail that goes into all these journal articles.
Indeed. The studies in these articles are being conducted by scientists. They have PhDs. They've gone through this incredibly long training period. They are smart people. They're conscientious. They care about the truth. And if a study was published, it went through this gauntlet of getting through the reviewers and the editor of some journal. This peer review process is supposed to weed out the studies that are not worthy of being included in the canon of science.
Right.
Given all that, we should expect that published studies will replicate at a very high rate, which is to say, if you do the study over again, you'll get pretty much the same results. Maybe every now and then a study won't replicate because the scientist made some mistake, nobody caught it, or maybe the finding was a statistical fluke. That is possible. But surely, we expect the vast majority of the time the results of a study will replicate.
Right. With all of the peer reviewing and effort and
Indeed.
science-y, statistics-y.
Yes. There have been organized efforts to replicate studies across various fields in order to see how often the findings of a given field replicate. In psychology, there have been a number of papers in which the researchers redo published studies and evaluate whether they get similar results. So this was your question before. How often do studies replicate?
Right.
The basic headline finding is that the results of psychology studies replicate about 50% of the time.
Boo. Tomato.
Tomato indeed. This is really bad, isn't it?
That's really bad. I kind of thought it was higher.
This means if you open up a psychology journal, you turn to some random study, there's a 50% chance the results are just nonsense. The findings are garbage. The interpretation of the finding is meaningless. So you're going to be a counselor, professional counselor.
One day.
So you got to look at that research literature, like what are the best techniques? How do I treat this particular client? And then it's like, oh, 50% of the studies, it's not going to give me useful information.
Exactly.
That's not good.
And I'm like, well, then what do I do? How do I treat this? What's the best approach? And science says, I don't know.
We'll talk about how to evaluate research next episode.
That's exciting.
We should keep in mind the fact that science is heavily subsidized. The people running these studies work at universities. They are taking a salary from their university. The university gets tons of money from the government. Also, the research grants that fund the scientists largely come from the government, which means it's funded by taxes. Money is being taken out of your pocket to produce this garbage science.
Guys, come on now.
Garbage science leads to a misinformed public. Psychology textbooks will contain some findings that have failed to replicate. There are TED Talks about psychology findings that are just nonsense. There are popular books about nonsense psychology. Bad science is setting our money on fire. It's making everyone stupider.
Yes, agree.
This replication crisis is not limited to psychology. One study found that around 40% of experimental studies in economics fail to replicate. A study of papers in cancer biology found that positive findings only replicated 40% of the time.
Wow.
A
That's not a lot.
survey of scientists found that more than 70% of them had tried and failed to replicate the results of another scientist, including 87% of chemists, 77% of biologists, 69% of physicists and engineers, 67% of medical researchers, 64% of earth and environmental scientists, and 62% of all others.
That's very high percentages.
There's a number of reasons for the replication crisis. One reason for the replication crisis has to do with the incentives that scientists operate under. If you are hired as a professor at a university, your first 6 or 7 years, you are working towards tenure. If you receive tenure, that means it's very hard to fire you. You basically have a guaranteed job for life, assuming you don't do anything too egregious. If you are at a research-focused university, you're mostly evaluated based on your research output, and specifically, the most important factors are the number of papers you have published and the prestige of the journals that you published those papers in. If you publish lots of papers in prestigious journals, you will get promoted, you will get tenure. If you don't publish enough papers, you will get fired.
So it's all about that tenure.
It's all about that tenure.
Yeah.
Getting fired as a scientist is especially bad because getting an academic position is ridiculously difficult to begin with. And in any given year, there's only going to be a certain number of universities hiring someone in your particular specialty. So if you get fired and you somehow manage to get a position somewhere else, it's basically guaranteed you're going to have to move. So you're going to have to restart your life somewhere else, and you may not have much choice over where that somewhere else is.
Right.
Aside from job security, the number and prestige of your publications is the way that scientists measure status. Every subculture has a way of measuring status and putting people into a hierarchy. For example, if you are sucked into the culture of Twitter, maybe you care a lot about your number of followers. If you're on a football team, maybe you care about your team winning the most games. Scientists care about publications. It is their measure of coolness. Researchers with lots of publications are cool and impressive. Researchers with few publications are uncool and unimpressive. The results of this kind of incentive structure is scientists are, by and large, obsessed with producing as many journal articles as they can. Scientists are motivated to do whatever leads to publishing the most articles in the most prestigious journals. This is not a perfect system. Can you venture a guess as to why?
Is it more quantitative based or qualitative?
Yeah, that's one way of putting it. There's a misalignment between what we care about and what scientists are incentivized to do. So
Yeah,
we care about the truth and scientific progress and innovations, which you could say those are qualitative.
right.
But those sorts of things are rather hard to judge. So instead, scientists are evaluated based on something quantitative, their publication record, which is correlated with, but not exactly the same thing as scientific progress.
Right.
And since scientists are going to be evaluated based on their publication record, that's what they're going to optimize for. They're not going to optimize for doing important research. They're going to optimize for generating as many publications as they can.
Yeah, that makes sense. It's like a hedonic treadmill in a way of publications.
Here's the rub. It's easier to generate lots of publications if you are willing to bend or break the rules of science.
Ooh, more tomatoes.
There are all sorts of bad research practices that can make it more likely that you get the results you want. If you are willing to indulge in these bad research practices, you can produce more publications, which means more status and possibly more financial security. So, unsurprisingly, many scientists engage in bad research practices. The badness of these practices varies quite a bit. So, I'll talk about some of these bad practices, starting with the worst.
Okay, let's hear it.
The worst of the worst when it comes to scientific research is data fabrication. This means you just make up the data. Instead of running a study, you just type numbers into a spreadsheet and pretend you got those numbers from a study.
That's terrible, guys.
It's terrible. It's
That's
terrible.
terrible. Don't do that.
Obviously, if you're making up the data, you can support whatever hypothesis you want.
Yeah. You could do whatever you want. You're playing God there.
Yes, you're playing science god.
It's an oxymoron.
There are several well-known cases of data fabrication. Maybe the most famous case is Diederik Stapel. You familiar with Stapel?
I don't think so.
He was a social psychologist. He produced lots of publications in the most prestigious journals. He did this through a research technique known as lying. He just made it all up. He would write articles where he would go into detail about studies he conducted, but he never conducted the study. He just made up the results.
He is a very creative liar. How skilled of him.
Yeah, very strange. Eventually, his collaborators figured out that something was very wrong and he got caught.
Good, as he should. Straight to jail.
Well, you don't go to jail.
Straight to the bottom of the hierarchy.
Yeah. He got fired. I don't think he
Good.
technically broke any laws, but this kind of data fabrication, it's probably quite rare. It's a really strange thing if you think about it. The training to be a researcher is so extensive and onerous to spend so many years of your life training to do research. And then when you finally get the chance to do it full time, you do fake research instead.
Right? Why are you putting so much effort
Yeah,
into lie? Just do the thing.
It's such a bizarre thing from the outside. Next on the list of scientific sins is data falsification. This refers to deleting some of your data for the purpose of making your results look better, or altering some of your data to make your results look better. In this case, you actually did conduct a study, but the data did not quite turn out as you hoped, so you changed some things here and there to make the data more pretty.
Like moving the outliers and such.
Yeah.
Yeah.
So you have somebody who produces a very unusual score, an outlier, and maybe you're like, oh, I remember that participant. I think they were drunk when they were in the study. I'm just gonna go ahead and delete that. Oh, that makes my data look a lot better.
Right.
So maybe you can like tell yourself a story where it feels justifiable.
Oh, he was drunk, so, Probably shouldn't have been in the study anyways.
Obviously, data falsification is bad, and no scientist should ever do it. In surveys, somewhere around 2% of researchers admit to fabricating or falsifying data.
Guys.
And that's the percent that admits to it, so, the real percentage is probably higher. Somewhere around 18% of researchers will say they know someone who has fabricated or falsified data.
Right, asking for a friend.
Yeah. In my estimation, fabrication and falsification are important issues, but they're not the main reason for the replication crisis.
Right. What is it then?
Well, there are a number of research practices that can make it more likely that you get the results you want, but without having to fabricate or falsify data.
Such as?
These are questionable research practices, QRPs.
Okay.
And we'll go into it, but I'll say that many of these are in a moral gray zone. They are considered not as bad as fabricating or falsifying data, which is probably a big reason why these kinds of practices are very common. I was taught to do these things, I will say. When I was a grad student, I was told to do these sorts of things explicitly.
That's audacious of them.
These sorts of practices can severely decrease the replicability of a study, and lots of researchers engage in these practices, so lots of findings don't replicate. So this is what I think is the main culprit for the replication crisis, these quote-unquote questionable research practices.
Right.
So let's dive into it. One questionable research practice is p-hacking. Have you ever heard of p-hacking?
No.
Okay. The name p-hacking comes from the way that social scientists do statistics. They use a procedure known as null hypothesis significance testing, in which you calculate a number known as a p-value, and you see if that p-value is below some threshold. The typical threshold is 0.05. Adana, you're probably familiar with what I'm talking about.
Right, I am.
If you run a study, you test your hypothesis, you find that your p-value is greater than 0.05, that is generally interpreted as meaning you did not support your hypothesis. If you don't support your hypothesis, if you find nothing interesting, it'll be very hard to publish your results. Null results aren't interesting. Nobody cares about a new cancer drug that doesn't work. The scientific community wants to hear about a new drug that does work. So, if you find that your idea is wrong or your practical application is ineffective, that's not the kind of thing journal editors want to publish. Researchers are therefore motivated to do what it takes to support their hypothesis, meaning get that p-value below 0.05.
Right.
There are various ways of gaming the system to make it more likely to get a p-value below 0.05. These methods rely on the fact that if you run lots of statistical tests, eventually you will get a p-value less than 0.05 just due to random chance. So if you want to game the system, you can run lots and lots of tests, and eventually you'll find something. This is not what you're supposed to do, and there are methods of correcting for this, but you can ignore all of that if you want to.
Interesting.
Here's an example. Say you run 100 participants through your study, meaning you get data from 100 people. You run your statistical test, you look at the p-value. If it's greater than 0.05, you run another 10 people. Check the p-value again. If it's above 0.05, run another 10 people. If you repeat this process long enough, just by random chance, you'll probably get a p-value below 0.05 at some point.
Yeah, that makes sense.
Other questionable research practices involve using lots of measures or running lots of conditions. This will result in running lots of tests. then whichever test didn't turn out the way you wanted, you just don't report that in the paper. You pretend it didn't happen. If you do this, you're not lying, you're not making up data, you're just not reporting all the data you collected.
Technically, you're only omitting part of the truth.
Yeah.
Okay. Or if you run like this condition, but this condition with this extra facet, and this condition, but with the control, but with this facet, and yes.
So when it comes to p hacking, there's a bunch of other stuff you could do, but I'll leave it at that. Suffice it to say, a researcher can tip the scales in their favor without being a complete liar, pants on fire. When you use these questionable research practices, it is possible that your findings are genuine. They aren't literally made up. But the more you do this kind of thing, the more you p-hack, the higher your false positive rate is going to be. You make it more and more likely your findings are nonsense. And in practice, questionable research practices are common, so lots of findings are nonsense.
Big sigh of disappointment.
Another contributor to the replication crisis is publication bias. The research that appears in the published literature is not representative of all the studies that have actually been conducted. This is largely driven by the fact that journal editors want to publish interesting, exciting results. Right. Editors want to publish papers where the scientists found something surprising. If an editor is really effective at publishing exciting papers in their journal is going to be cited frequently by scientists. This raises the prestige of the journal, which increases the status of the editor. And if you edit a very prestigious journal, it means you must be an important figure in the field. So, editors are incentivized to publish studies that found something surprising and interesting. As we discussed before, if you get a positive result that supports your hypothesis, that's usually going to be a lot easier to publish than a null result that indicates you found nothing. Therefore, there is a publication bias whereby the papers that actually end up getting published are the ones that produced positive, interesting results, whereas papers that don't get published are the ones that found less interesting null results. The published literature will not well represent all the studies that have been conducted. It will only represent studies that got positive results.
Right. But I think it's so important to note that maybe research can show a positive result, but it's just as important to know what it's not, what the answer is not, as much as what the answer is.
It's true. Null results are important.
Especially with like your cancer example from earlier, we need to know that that's not the cure for cancer.
And you're absolutely right. But the editors are incentivized to publish the sexy findings.
Boo.
This publication bias can lead to a selection effect where findings, which are the result of researcher error or randomness, get too much credence.
Mm-hmm.
Here's an example of what I'm talking about. Imagine some theory. We will call it Theory X. Theory X is wrong, but researchers don't yet know whether it's right or wrong. So 20 researchers each separately conduct a study to test the predictions of Theory X. Since Theory X is wrong, 19 out of 20 of these researchers get null results. They find nothing interesting, and they don't bother trying to publish the results of their study because editors don't care about null results. One researcher out of 20 gets positive, interesting results, and this is just due to a statistical fluke. They found evidence for Theory X due to randomness, which is a thing that could happen when you're doing science. Since this finding is interesting, they're able to publish it in a scientific journal. When you look through the scientific literature for studies of Theory X, you will only find the study that supports Theory X. you will not find those 19 studies that failed to support Theory X. So, from your perspective, Theory X is fully supported by the scientific literature.
That's why we need replication, guys. And that's why we can't find it.
So, the research literature is misleading, which is bad, but also it exacerbates the replication crisis.
Yes.
Because researchers are engaging in these questionable research practices, the rate of false positives is going to be very high, possibly much higher than the rate of false negatives, meaning studies that purport to find something that isn't there, that's going to be more common than studies that fail to find something that is there.
Yes.
Okay. If journals are preferentially publishing positive results, then they are publishing just those studies which are least likely to replicate.
Yes.
In other words, if all studies were published, the replication rate would be higher because null results replicate better than positive results.
Yeah, absolutely.
So that cancer, biology, replication effort that I talked about earlier found that 40% of positive results replicate. That same paper found that 80% of null results replicate. Positive findings don't replicate as well because they're the product of questionable research practices, which severely inflate the false positive rate.
That makes a lot of sense. And it's
So,
disappointing.
so scientists are generally aware of these problems that we're talking about. Over the past 10 years, there have been improvements. Journals and funding agencies care more about replication. It's more common for researchers to pre-register their studies, which means before conducting the study, the researchers publicly declare exactly what their hypothesis is and what statistical tests they're going to run. It's now more common for journals to require researchers to submit their raw data. Researchers are moving towards using larger sample sizes, which is a whole other issue I didn't dive into. So things are getting better, but still, the rigor of scientific research is nowhere near optimal.
One day, maybe.
Well, even if half of science is nonsense, the other half is pretty cool, isn't it?
Yeah, always.
And we will continue our exploration of the good half of science on the next episode of The Scientific Worldview.